Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem as usual, having been chosen from the book Modern Physics by Kenneth S. Crane. Statement of the problem is, what is the distance of closest approach when alpha particles of kinetic energy 6.0 million electron volt are scattered by a thin copper foil. Dear students, in our previous problem, we have dealt with almost similar situation. Okay. The only difference is that in that problem, in place of copper foil, gold nucleus was used. Moreover, kinetic energy was not given, and we had to find kinetic energy while distance d was given. Okay. Dear students, in our previous previous problem, we had given enough time to problem of this nature. Okay, almost 10 helping tools were introduced just in order to develop a foundation to understand the basis of the problem properly. Okay, but in this in this problem, all those steps are not being repeated. Okay, because actually our purpose is not just to prolong our videos. Okay, so no doubt this problem is also exactly of the same nature, and we are in a position to repeat all those previous 10 helping tools in this problem, but we are taking into consideration a few of those helping tools. Okay, so as usual, we first move to our helping tools. Okay, helping tool number 1, distance of closest approach d is equal to 1 over 4 pi epsilon naught z square over k, where k is kinetic energy. 1z is for alpha particle, which is similar to helium 4 nucleus, and 1z is for copper foil. Okay, in previous case other z was for gold nucleus. Okay, E is elementary charge, pi is 22 by 7, approximately equal to 3.14. Value of epsilon naught is also given in a helping tool, and combined value of 1 over 4 pi epsilon naught is usually denoted by small k and is termed as a Coulomb constant or electrostatic constant. Okay, and in addition to this combined value of E square over 4 pi epsilon naught is also given in the table which has been included in our tool hereinafter. Okay, so I think however one difference in previous problem or video and in this problem is that in previous problem or video we had to shift k in place of d and d in place of k. Okay, but here kinetic energy is given 6.0 million electron volt, so we do not need to disturb this formula. Okay, this expression. Okay, now we come towards the tool number 2. Okay, Tool number 2 says alpha particle is identical to a helium 4 nucleus with electric charge plus 2e. Dear students, here a part of a relevant table has been shown in the shape of a snapshot. Okay, actual length of this table is spreading over many pages, but we have just cut paste only that part of that table which deals with hydrogen and helium. Okay, so He, its Z is 2, and we are concerned with this value. Okay, 4.002603 etc. But even here we are not concerned with this 4, we are only concerned with this 2. Okay, now similarly we move to copper. Atomic number Z of copper, Latin cuprum. Okay, copper is its usual name, but its chemical name or a name according to chemistry, or I do not know whether it basically belongs to chemistry or physics. Anyhow, this term, that is cuprum, comes from Latin. Okay, and according to cuprum, its symbol is Cu. Okay, its name is copper, COPPER, but its symbol is not CO, rather its symbol is Cu, because copper in Latin is called cuprum, so its symbol is Cu. Okay, this detail is very lengthy. Actually, Latin words are usually a disturbed shape of present existing form. Okay, and anyhow we leave this discussion. Okay, here its Z atomic number is 29, and only we are concerned with this. However, its remaining properties are shown in this form. Okay, this is just for our understanding and concept clearance. Okay, next, tool number 3. Dear students, in this tool electric charge E equal to this is given. Okay, moreover, actually the most important thing which will be used here is that here E square over 4 pi epsilon naught combined value of this is given. Okay, we will use this value. We can, in our previous problem or previous video, we had counter checked this value by putting values of E, pi and epsilon naught separately in this expression, and we solved all these values, and only one or two perhaps conversion factors were used, and its value was its value had come exactly equal to this value. Okay, but in this problem we will not repeat this practice. Okay, it is enough to say that in this problem we will use this combined value. Okay, E square over 4 pi epsilon naught. Okay, tool number 4. According to tool number 4, the combined value of 1 over 4 pi epsilon naught is given, which is 8.99 into 10 to power 9 Newton meter square per coulomb square, and this whole expression is denoted by small k. Okay, in this expression the quantity epsilon naught, called the permittivity constant sometimes appears separately in equations, and is epsilon naught is equal to 8.85 into 10 to power minus 12 coulomb square per Newton meter square. Okay, This is just for our assistance and understanding. Otherwise we do not need tool number 4, okay, because we have this combined value of E square over 4 pi epsilon naught. In presence of this value we do not need these values, okay. Anyhow we should know this thing, okay. Now we come to its solution. We know that distance of closest approach is given by d is equal to 1 over 4 pi epsilon naught z e square over k, okay. We have reshaped this formula in this form, that is we have separated this portion because we have value of this portion in a table multiplied with z over k. Here is one z is for alpha particle, that is helium nucleus, one z is for copper foil, and k is kinetic energy, which is given in the statement as 6.0 million electron volt or 6,000,000 electron volt, okay. That is 6 along with 6 along with 6 zeros, and in the presence of these 6 zeros it will be called electron volt. But when we write it as simply 6, then it will be called million electron volt, okay. So nothing left. In place of this we have used this value from table, 1.440 million electron volt into femtometer, million electron volt femtometer multiplied with 2 into 29, okay. 2 is for alpha particle, that is helium nucleus, 29 is for copper foil, and kinetic energy is given as 6.0 into million electron volt, okay. Here million electron volt will be cancelled with million electron volt and our answer will be in femtometer. After simplifying it will become 13.92 femtometer. We can also write it as 14 femtometer, okay. It is a matter of discussion. Otherwise our problem has been solved successfully. This is the end of this problem. This is the end of this video. Till next video, Allah Hafiz.